Hi, and welcome to Allen High School's discussion of gas laws at the pre-AP chemistry level. And, whoa, did not want that. All right, let's take a look at our next law. This one is fondly known as PreAP, and you'll see why we call it that in just a minute. Now, when we talked about kinetic molecular theory, which you need to know those premises of kinetic molecular theory, gases that behave according to the kinetic molecular theory are called ideal gases. Now, this tends to happen at relatively high temperatures and low pressures. And it happens with gases that have few, if any, intermolecular forces. Okay, so water vapor is not one of them, because water has such strong intermolecular forces. You could probably get it to behave ideally, but you'd have to have very, very low pressures and very, very high temperatures. Okay, up till now, we've spent a lot of time talking about changes in state with our combined. PreAP isn't about changes. It's one state of the gas, and it relates all of them: pressure, volume, moles, and temperature, the four variables that we have discussed up till now. And they are related. If I rearranged this, PV over NT are equal to a constant. So if I were to calculate any state and took PV over NT, I would find that they're equivalent to this ideal or universal gas constant. Ideal gas constant or universal gas constant. It's called both. Okay? Now, when we do this, when we shift to this formula, PreAP, right? I hope you get that. When we shift to this formula, we start to limit ourselves in terms of units, and that's because of R, and I'll show you the values in a minute. But volume must be in liters, moles are in moles, I mean that's just kind of a given, and temperature has to be in Kelvin, right? So the real new thing are the liters. Now pressure has to match the value we use for our gas constant. There's three ideal gas constants. These are the units. That is not a formula. Some students look at those rather complicated units and think it's a formula to plug into. That's not. Those are the units that we use. And so what we find is if pressure is in atmospheres, then we need to grab this, our value, 0.0821, and plug it in. If pressure is in torrs, we'll substitute 62.4 in for torr, and if it's in kilopascals, we'll substitute in 8.314. Okay. Now we're going to see a few others as well, so you want to be very careful to list your givens. So we've got three forms of the ideal gas law. This form, it's given in your formula chart. Something similar, in your formula chart, you're given that moles are equal to mass over molar mass. So you can combine the two formulas and get to this one, or do it in two steps. Convert mass to moles using molar mass and then substitute into PreAP. That's just fine. You don't have to use this formula. This next one is really handy because it's common to report densities of gases, and I learned this when I was grading the AP formula. I used to always have to derive it in the form I used, and ever since I've heard this, I've not forgotten it. We call this is modified from what I was told, but this is called the meow meow formula. MM stands for molar mass, so this is the meow meow because cats put dirt, DRT, over their P. Okay. It's not the most pleasant image in your mind, but I'll tell you, it works. And that's an excellent one that you want to memorize. It is possible to rearrange this and solve for mass over volume, but I think that's kind of hard and complicated. And y'all are young, you can memorize. That's an easy formula to memorize. So let's substitute in here. What is my molar mass? So molar mass is my unknown. tells me I have a diatomic gas. So it's some element with two of them. Right? I have a mass equal to 1.60 grams. I have a volume equal to 500 milliliters. A pressure equal to 2,500. Now, a millimeter mercury is identical to a torr. There's no conversions for that. And a temperature equal to 350 Kelvin. Now, one of the ways you know this is PreAP is you're only given one of each variable. There's not two volumes or two temperatures or two pressures. Okay. Now, let's check our units. You might want to write your equation. That can be handy here. We're going to do PV is equal to nRT. Oops, my mind got ahead of my mouth there. Okay, or my hand. PV is equal to nRT. Now, you could certainly do this in two steps. Convert mass to moles using molar mass and then substitute. Or you could use PV is equal to mass over molar mass times RT. So since we're using this PreAP, we have to be careful with units. And let's look at some things that we need to watch. Volume has to be in liters. So that's 0.500 liters. You should be able to do that without showing the work, but if you are prone to going the wrong direction, which some are, let's see, it would be 1E. Whoops, let me kind of erase that. I messed that up there. Sorry. Okay, if you're prone to moving it in the wrong direction, 1E minus 3 liters for every 1 milliliter, I would do that. Torr is okay, Kelvin's okay, mass is okay, but because of this, let's go ahead and write our gas constant. It's 62.4 when we're dealing with torr. Now we're ready to substitute and solve. Now, I like to solve a literal equation. That means without values. So molar mass is I'm going to cross multiply and bring my molar mass over to this side. So it's mass RT. And then since PV would be multiplied here, I divide them when I cross multiply to get them to the other side. I like to use this. If you want to go mass to moles, use molar mass and then plug into here. That's just fine. Whatever floats your boat, whatever works best for your mind, as long as all work leading up to the final answer is shown. So now that I've checked on my units, I don't have to carry them through the question. I can just substitute and solve. And when I am done, I get 28 grams per mole. Now that's equal to X2. So that means if I have to divide that by 2 in order to find out what X is. And so if I divide that by 2, I get 14 grams per mole, which would make that nitrogen. And my law name is the ideal, not PreAP. Please don't put PreAP there. That's its nickname. Ideal gas law. Okay? All right. So I hope things are going well in class with your problem solving. If not, you know you need to get that consultant. That's me, over to your desk as soon as you can. So until then, this is signing off.